I'm here at the Western Portal in Kensington. The Western Portal is the actual retrieval shaft for the TBM. I'm incredibly excited to see Joan arrive at the Western Portal, and Meg has also just broke through just by side of Joan. It's been months of hard work, really proud of the achievement. So the breakthrough itself takes place over several days. The more traditional understanding of a breakthrough is when the machine digs through the pile wall, so that happens over a course of about a shift. But the breakthrough is not completed until the machine is completely pushed into the shaft. The last ring in the tunnel is built and is successfully grouted, and the back of the shield is pushed through the seal. The breakthrough at the Western Portal included two systems to control the slurry pressure that's being applied by the TBM. So the first system is a seal, and that basically seals the slurry at pressure around the skin of the machine. And we also flood the chamber in the portal as a secondary measure. If the seal were to fail or something were to go not according to plan, we have to inspect for water ingress or any ground movement. Once we're confident that that's occurred, we then start the final stages of pushing the TBM into the shaft. We then drain the water, and then we're monitoring for groundwater ingress as we're draining that water. Now, if there's any signs that there's some water ingress, we'll fill the shaft back up. We haven't had to do that, which is great. But once the process is finished, we actually use that water and send it back to Arden Street, where it's used to batch fresh slurry in the slurry treatment plant. So the TBM is a mixed shield tunnel boring machine that's equipped to go through some of the more challenging ground conditions with quite a vast array of different cutting tools. So there are disc cutters, which are primarily there to go through rock or hard ground conditions. We also have scraping tools that pull that material in and enable it to pass through the openings of the cutter head. Now those disc cutters need to be changed occasionally, and we have sensors on the cutter head that tell us when there are signs that those tools have been worn down to a point where they need to be replaced. Because of the ground conditions around us and the sensitive location, we sometimes have to do that under compressed air, which is our hyperbaric work. So the TBM's equipped with a compressed air chamber, so it enables us to do work within the machine itself at a pressure that's equivalent to the groundwater pressure. So our crews have to be specifically trained for that work. They have to be medically fit for that work. It can be quite warm, it's a confined space, but the guys are really well trained to do it, and it's something that has to go very, very smoothly because of the environment that they're working in. So during the bored tunnel excavation process, we have to monitor for ground movement, we monitor for changes in groundwater pressure, we have to monitor various structures and rail infrastructure. The TBM itself is equipped with sensors and telemetry to tell us what's going on in the excavation chamber. The calculations that we do to manage those pressures depends on a variety of different factors. So the ground investigation that we do, we use that data to build up a model, and then we pre-calculate what those pressures should be and what the expected movement should be. We monitor the machine as it slowly progresses. We then use that data to feed back into those calculations to refine them even further. Now, we've successfully gone from Arden to Western Portal, which proved that a lot of our modelling was correct and accurate, and the instrumentation system and the monitoring was used to validate what our predictions were. So we've also further refined those models for going back towards Parkville and other sections of the drive. Joan was launched in 2019. It started off in an area that's more commonly referred to as the Yarra Delta, so that includes Coot Island Silt, Fisherman's Bend Silt, very young ground formation, very soft geology, very sensitive to ground movement. After that, there's a more well-known Werribee Formation. It's quite common around Melbourne, but after that we're in the ground conditions that are referred to as the older volcanic. That includes quite stiff clay, but it also can include very, very competent basalt. On top of that area, we had several live rail corridors where services could not be disrupted. We also had to tunnel underneath Moonee Ponds Creek beside the CityLink piers that would hold up the CityLink structure. After that, we had to tunnel underneath more bridges, more rail infrastructure without disrupting services. And when we broke through finally here at the Western Portal, we were also very close to live rail and South Kensington train station. It's an incredible achievement to go over such a distance in such challenging ground with the surface infrastructure we have without disrupting any services. So I'm incredibly proud to see Joan here and seeing Meg arrive so we can celebrate another milestone for the project. So the first TBM section to be removed is the cutter head. Once the cutter head is off, there is a slow process of carefully removing each section of the TBM for transport, and then the shield is slowly broken down into smaller components where it will be trucked using oversized transport vehicles back to Arden Street, where it will be reassembled and relaunched towards Parkville.